Finding scale factor. Find the scale factor from the small to large shape and from the large to small shape. What I would like you to do first is to copy down these shapes. So go ahead and copy them down and pause the video, and then we will talk about how to find each of the scale factors. Okay, so let's first talk about the scale factor from the small to the large shape. So scale factor is a multiplier. That means to go from here to here, we have to multiply. Now, what I'm going to do is set up a ratio, and I'm going to pick two sides of my, or two dimensions of my shape. So I am going to choose the 6 and the 3. And what I'm going to do is I'm going to set up a ratio, 6/3. I'm going to put the dimension of the large shape as my numerator and the small shape as my denominator. And 6/3 simplifies to 2. So my scale factor from my small to my large is 2, because I multiply the dimensions of my small shape by 2 to get my large shape. So let's talk about now the large shape to the small shape. Again, you pick two dimensions. Let's this time choose 8 and 4. You pick your two dimensions and set up your ratio. So I'm going to put my small shape as my numerator and my large shape as my denominator. And that simplifies to 1/2. So what that means is that I multiply my large shape by 1/2 to get my small shape. What's really important to notice is that when you're going from a small to a larger shape, when you are increasing in size, your scale factor is larger than 1. In order to make something bigger, you have to multiply it by a scale factor larger than 1. But when we are going from a large to a small shape, we are making something smaller. So you have to multiply by a scale factor that is smaller than 1. Thus, our scale factor is 1/2. All right, let's look at the next one. So let's talk about the scale factor from the small to the large shape. So think about whether or not, if you're going from small to large, does your scale factor have to be bigger or smaller than 1? Remember, it has to be bigger than 1. We are going from small to large, so we need to multiply by something larger than 1. So you're going to take your large shape dimension and use that as your numerator and put it over the denominator of the corresponding side of your smaller shape. And 21/14 simplifies to 3/2. So what that means is that I multiply my small shape by 3/2 to get my large shape. We could also say 1 and 1/2. That's fine as well. Now let's talk about your large to your small shape. So remember, if you're going from large to small, your scale factor needs to be smaller than 1. You are making something smaller. So we're going to take our dimension of our small shape and use that as a denominator over the dimension of our large shape. So that simplifies to 2/3. So to go from the large to the small shape, I multiply by a scale factor of 2/3. All right, let's look at the last one. Let's talk about small to large. So do we want our scale factor to be larger or smaller than 1? We want it to be larger than 1. We are taking something small and making it larger. So you're going to choose the dimension of your large shape and put it over the dimension of your small shape. And 48/40 simplifies to 6/5. That means, or we could also call it 1 1/5. That means that I multiply my small figure by 1 1/5 or 6/5 to get my large shape. Now let's talk about large to small. So we're going to take our small shape over our large shape, and that simplifies to 5/6. So to go from your large to your small shape, you multiply by a scale factor of 5/6. So always make sure that you reason through these problems and you make sure that your scale factor makes sense. If you're going from small to large, you need a scale factor larger than 1. Large to small, a scale factor smaller than 1. Here's an example of an application problem where you would use scale factor. We can use scale factor to determine unknown measurements. So for example, in this problem, we have a person who's 5 feet tall casting a shadow that is 4 feet long, and they're standing next to a tree that casts a shadow of 10 feet. So we need to use similar figures to find out how tall the tree is. So we want to go from the man to the tree, or from our small figure to our large figure. And the reason that I'm saying it a small figure or a large figure is because you actually can see that what we really have are similar triangles. So let's talk about the scale factor from small to large. So I'm going to take I'm going to use 10 feet and put it over my corresponding shadow length of 4 feet. So 10/4 I'm going to simplify to 5/2, and I could also go ahead and simplify that to 2.5, but I prefer improper fractions. So what I'm saying is that my scale factor is 5/2. So what this means is that 4 over 1 times 5/2 should give us 10 feet. And that's 20 halves, and that is 10 feet. So we are correct. So now let's apply that scale factor to the man's height. So we're going to take 5 feet, so 5 over 1, and multiply it by our scale factor of 5/2 to get 25 halves, which simplifies to 12.5 feet, which is the height of the tree.